Let z1 and z2 be two complex numbers which are the roots of the given quadratic equation x square plus px plus q square is equal to 0. Therefore, the sum of the roots of this equation z1 plus z2 is equal to minus p, and the product of the roots of this equation z1 times z2 is equal to q square. Let's denote these two equations by 1 and 2 respectively. Now take the square of the first equation and divide by the second equation. We get z1 plus z2 whole square divided by z1 z2 is equal to p square upon q square. This implies that p square upon q square is equal to z1 square plus z2 square plus 2 times z1 z2 divided by z1 times z2. And this is equal to z1 upon z2 plus z2 upon z1 plus 2. Now on the right hand side, multiply and divide the first term by the conjugate of z2 and multiply and divide the second term on the right hand side by the conjugate of z1. Therefore, the right hand side can be written as z1 times the conjugate of z2 divided by the square of the absolute value of z2 plus z2 times the conjugate of z1 divided by the square of the absolute value of z1 plus 2. Now we are given that the absolute value of z1 is equal to the absolute value of z2, and say this is equal to r. Therefore, using this result, we get p square upon q square is equal to z1 times the conjugate of z2 plus z2 times the conjugate of z1 upon r square plus 2. And this can be written as z1 times the conjugate of z2 plus the conjugate of z1 times the conjugate of z2 upon r square plus 2. Now let's assume that the complex number z1 times the conjugate of z2 is equal to a plus ib, where a and b are real numbers. Therefore, the conjugate of z1 times the conjugate of z2 is equal to a minus ib. Adding the two, we get z1 times the conjugate of z2 plus the conjugate of z1 times the conjugate of z2 is equal to a plus ib plus a minus ib. The imaginary terms cancel on the right hand side and we get 2a, and note that this is equal to 2 times the real part of the complex number z1 times the conjugate of z2. Using this result, the above equation can be written as p square upon q square is equal to 2 times the real part of the product of z1 and the conjugate of z2 divided by r square plus 2. Note that the right hand side is a real number, and it therefore follows that p upon q is a real number. And this is the required answer.